Alright, this is a video if you missed last week over electrochemical cells. So I'll go ahead and do this worksheet with you and you guys can get a little bit of reteaching. So basically what you have here is what we call a voltaic cell. I know it's a voltaic cell for two reasons. One, there's two individual containers here where each of the half cells are located, as well as a salt bridge here that connects the two. This is a copper wire that will conduct electric current, and that would be attached to a voltmeter that would give us a voltage. So the first thing that we're going to do is take a look at the overall balanced cell reaction. So you'll see here that we have Ag1 plus and solid cadmium, and it goes to Ag solid and cadmium 2 plus. So the first thing you need to do is take a look at the two individual reactions and write them out. So I have Ag1 plus going to solid Ag. And the next thing we need to do is take a look at what's happening here. I'm going from a +1 to a 0. And so that means I'm getting reduced. So this is the reduction half reaction. And remember that oil rig oxidation is losing and reduction is gaining an electron. So in that half reaction, I would need to show that one electron is being gained on the reactant side. The other reaction here is cadmium 0 going to cadmium 2 plus. So when I'm getting bigger in number, that is oxidation. Remember that I'm going to write here that cadmium is moving to cadmium 2 plus. And I'm going to ask myself, what is oxidation? Oxidation is losing electrons. So I would need to show the electrons over here. And how do I know it's 2? Well, if I go from 0 to +2, that means that I must have lost 2 electrons. So to get the balanced chemical equation here, we need to have the electrons be both equal to 2. So I have a 2 and a 1 here. I'm going to multiply that top equation by 2, which is going to give me 2 electrons plus 2 Ag1 plus yields 2 Ag. So all I did was multiply this top equation by 2. So I'm going to go ahead and mark that out now since I've already done that. And now it's time to go ahead and gather like terms. So here is a yield arrow. On the right hand side is 2 electrons. On the left hand side is 2 electrons. Those will cancel. And then I'm just going to write what I have left. Solid cadmium reacts with 2 silver ions to form cadmium 2 plus and solid silver. And we're going to make sure this balances, and 2 solid silver. We're going to make sure that this balances in charge and number. 1 cadmium, 2 silvers and 2 silvers, 2 1 pluses on this side. On the right hand side we have 2 pluses, and so this is the balanced overall reaction. It balances in atom and it also balances by charge. So you want to check those two things. All right, use the reduction potential table to calculate the cell potential. So you'll be given a chart like this, and you'll need to find both species on the chart. So the first one we had was cadmium, Cd2 plus. So I'm going to look until I find Cd2 plus, and that one is, let's see here, I'm going to have to look without looking at the screen because I can't see very well. I'm sure you guys have already found it. There it is. It's terrible getting old. Alright, so there's my cadmium 2 plus going to solid cadmium. And the other species was going to be silver 1 plus going to solid silver. So again, here is that reaction right here. So you want to find your two reactions here. Alright, so which one of these reactions matches the half reaction? This is Ag plus going to Ag. So I'm going to check here. This is Ag plus going to Ag. That seems to match. Ag plus going to Ag. Let's take a look here. This is Cd2 plus going to Cd. If we take a look here, we're going from Cd to Cd2 plus. So that reaction has been switched. So what I'm going to do is I'm going to write down the cell potential that matches the reaction that does not switch. So for my silver, it's 0.80 volts. We measure potential in volts. And then since this one here is the reverse reaction, instead of going 2 plus to 0, our equation goes from 0 to 2 plus. I need to switch the sign here, since the reaction is backwards, to a plus 0.4 volts. And we're going to add those together. 1.2 volts is equal to our overall cell potential. Okay? For the cell notation, you're going to have the oxidation followed by the reduction reaction. And we're going to do reactants followed by products, because that's how it goes in a equation. So the oxidation reactant would be CD. The oxidation product would be CD2+. So I'll say CD, draw a line, CD2+, draw 2 lines that represents the salt bridge. Reactant, reduction reactant is Ag+, and reduction product is going to be Ag. So again, this is just oxidation reactant product, double line representing the salt bridge, reduction reactant product. Okay. All right, this is spontaneous, and that is because our overall cell potential is greater than 0, or a positive number. Okay, so these are going to be spontaneous reactions. They will always end up being a positive, and we call that cell potential the E0 of the cell. So when the E0 is positive, again, positive 0.8 plus 0.4 gives us a positive 1.2. We say this is a spontaneous reaction. All right, the anode and the cathode. If you look here, we have CD0 going to CD2+. So going from 0 to 2+, we said was oxidation. Oxidation and ox occurs at the anode. So the anode would be the CD2+, so this would be the anode. And on this side, the Ag would be the cathode, because again, red cat. So if we go from 1 to 0, it's reduced. And so that's called the cathode, red cat. So we have the anode and the cathode now labeled. The electron flows, fat cat, from the anode to the cathode. So we would need to show the electron flowing from the anode to the cathode. It doesn't flow left to right. You find where the anode is, and you just make the electrons flow from the anode to the cathode. So I'm going to put here from the anode to the cathode. All right, the changes in mass. We talked about fat cat, and fat cat meant that the cathode was going to gain mass. So I say the cathode is going to gain mass, and if the cathode is gaining mass, then the anode is losing mass. All right, a solution of potassium chloride, here it is in the salt bridge, KCl. It says that that's in the salt bridge. What is the purpose? And the purpose is to balance the ionic charges. We know that as cadmium 2+ is losing 2 electrons, it is forming more cadmium 2+ here. So if this is the anode, the anion Cl- will flow to the anode. And since this is the cathode, the cation in the salt bridge K+ flows to the cathode. And again, that is simply to keep the ion charges balanced. Copper wire is a good choice for connecting the electrodes, because metals are good conductors. So this is about conducting electric current, and so we want to use a metal to conduct that electric current, or to allow the electrons to flow. And electrochemistry involves the changing of chemical to electrical energy, and it is a redox reaction, which is basically an oxidation reduction reaction. So this was the guided learning that we did in class, and we will have a pre-quiz followed by the real quiz.